continue with character problem. Now this let's get into yeah. Where's it? Yeah, there's okay. That's the first three elements of D, and alternatively you could select wait, what is D? Okay, if you want the and also if you want the last word of D, you could go D length D. Okay. If you want all of the word except the first one, you go D, put a minus sign here, 1. And if you want if it, if you want all the word except the third one, you go this. This is about exclude. Right. Now just so I can see clearly. Some other way of doing that without vector logic, you could go if I want to select the second and the last one, I could go D, and also you could put this vector here, or there's another way of doing this. You use another vector. I just override it from A. Is do I want the first vector? Yes. Nope. And do I want the second one? Yeah. Third one? Nope. Fourth one? Fifth one? And I got A. A is a Boolean vector. Now I want correspondingly the D vector. It's automatically gonna select something is true for me. Now this is what is very convenient about, or at least what I think is very convenient about it. Now let's get back to the question. I got a string. My string. Well, it's just convention rather how you name the words. It's the first number. Well, let's just make it interesting. Third. First. Okay. Okay. My string. What do we get? String. Now I want the second letter. Oh, it doesn't work. Alright, it doesn't really work like that. Now we go class my string character, and as you could go as vector D. This is a string vector. Okay, if I go as vector my string, what do we get? Level string. So vectors have levels. If I they will automatically neglect something that's the same in a vector. For example, if I do a little bit of, if I change the D a little, I append something. I gave it a sixth element, which is this. Now, what I do this as vector D. This is a string vector. Well, this appears twice, but in levels there are only one this. Well, this could be useful statistically. As you want to you want to say how many vectors have these have certain character, how many how many datas are males, how many data are female. You don't want to store the same word like class male or female for lots of times. You just want them to be a atomic thing, and then the factor help you to classify things. But anyway, let's just forget about it, because we'll get to that later in the statistic part. Now we get Boolean vectors. Now what is this called? Now this is called index of vector. Before we get to matrix, multidimensional array and something called data frame and tables, which are just statistical or data science kind of data frame, data sets. Some after all, there are different data types that help you manage the things that you want to analyze. And you could sometimes even define your own data type if it's necessary, but most of the time you don't have to. Alright, now for sequence there are lots of strategies to define sequences. Now if I want to, I just override it from A. If I want to repeat some number by some factors, what can I do? Like I want to repeat 30 by 10. Say I want, wait. Oh, okay. Each unexpected. Okay, you should always write the name of the function before the bracket. Okay. Now I get 1030. If I want 3010, you could just go, or you could, well, I made the same mistake again. Repeat, just rep. This is the function you're gonna use, right? And if you put question mark before the function in this bracket, you could get a help file somewhere there. Yeah. So you get x times. You could go. So the user function is that it has some default values, and you're gonna put something that of the input of the function correspondingly in the same position. But this is not always true, because you could always specify the name of the function. For example, I want to repeat 10 by 30 times. Instead of doing that, well, remember what we could repeat each 30 times. My object x is 10. Now I get C. What's C? See, that's the same thing. What's B? Now I want the output B. You could go print B or just B. This is fine. This is not much difference. What if I go print B? Yeah, it's just showing me slightly different, but sometimes it's just different by the width of the screen. Also, if you squeeze the plot panel to narrow, sometimes it turns out to be a narrow, but most of the time you don't have to worry about that. They are the same thing. And B, it's just now. Is B and C the same thing? Yeah. It is comparing that each element of this. So to say the two function are the same thing, or the two objects are the same thing, you could go identity B and C. Wait, no, identity B is the same thing as C. Right, and if there's one, what if there's one false things? What if I name C of Nancy, which means the last element of C is false? It's for example 11. It's not 10. So if I go C, it's not the C anymore. Wait. You hit Control and Return to run things. Now, if I go B, if I just compare B and C like this, it might not be very intuitive because sometimes the vector is too big that it escapes the line. Now, a safer way of doing this, by comparing each element whether they are true or not, is that you put any B is not C, you get true. So there exists some B, which is some elements of B, which is not equal to the corresponding space, the corresponding element in the same space in C. This is possible, and also this could be the same. Some important thing here. If I want to figure out where that is, you could write some algorithm for that. But I'm not teaching you algorithm. I'm just doing a little bit of introduction of R. And you could, for string processing, there are lots of fun thing about them. And also you could go, we're after defining sequences, right? And from repetition we get, and also we get linear sequence. If you want a linear sequence D, let's say from 1 to 100, and I got D equals to C 1 to 100, and or we could always append something. For example, I just want the 1 to 29, and then 77 to 100. What can I do? Well, we could do pretty cool. And now I want the difference, which is the next one minus the previous one. What we can do is diff just difference of D. Now we get 1. Suddenly jump to 48. However, and this 1. That's not surprising. And some other useful way of difference is sequence. Now, use sequence, you can go a lot of different things about, but what I think most useful is from a number, say 0.1, to a number, say 1, and by 0.1. And yeah, get Z now. this is a linear sequence from 0.1 to 101 by the step of 0.1. You don't have to worry how many terms are there, or you could calculate it, but if you just want a sequence, generate a sequence, it's a quite easy way of doing it. Also, you get a d is a string factor, and I want d, the length of d, which is, well, the length of d. Where's d? Oh, we overwrote it. Anyway, let's just say I want the length of e. We got so many elements in e. I want each number of them. I want the sequence that consists of, say, this is the first element, this is the second element, third element, and so on. And I want to number them. Now here's the number. Here's the way we could do this. Sequence along e. Here we go. That's from 1 to 1. You could go from 1 to length e, but they're usually the same thing. But instead of, if you get e, the length of e is 0. If e is null, then you get some problem with this, but you're certainly not getting any problem with sequence along some factors. This is probably very useful when you're writing for loops, looping system. But you don't always have to use numeric vectors for a looping system, but you usually use them because of their convenience as index. Okay, that's for the defining sequences. And you could also bind two things together, like what I did here. Or you could go, let's just generate some sequence using the ep4 loops like this. For example, I want a Fibonacci sequence. Let's just say I want a Fibonacci sequence. Now you can't just do it like something. And I know you got some formula about Fibonacci sequence, but the easy way of doing this is by appending. I want the sequence to be numeric or vector. I want it to be say 100. And for I have fib. I have the first element, or first and second element is 1. Wait. Oh, we can't do that. We can just wait. What happened? Oh, we haven't defined it. Right. Or we could go, yeah. So what happens is you get 1 1 something 0 0 0 0. The rest of them is 0. Just to make it clear, but you don't have to do this. The rest of them, wait. It's missing, so that it's safer to use the program, just in case. Right. Now I'm gonna use for loop for sequence along the sequence, but the first one and second one is already there, so I'm only after if wait, we should have an index let's just make it I in seek alone. If I is, if we got put some statement here. This is not a very efficient way of generating, but the demonstration about the sequence for I. If I is in A. Why are we doing that? Because if it's not in A, if we already got a number here, for example 1 1, we can't get the previous term and previous 2 term here. So what's important here is that if I the ith factor actually we are using this as an index, as the ith elements is in A, so it doesn't apply when I equals 1 or 2. We gotta have call it the previous term and the other one. Right? Let's just see how it works. You could write a function for this. Uh-oh, it's not working. What? Oh, okay. We can't do that. This must be a function. Is NA must be a function. Yeah. Good. Let's just say fib. Now we we better turn this into integers. Wait. We made it empty, which is not. Okay. Now I hope to see what's going on here. Our sequence start with 1, 1, 2, 3, 5. 8, 13, 21, 34, 55, 89. No problem so far. But from that's 43, it marks 44, 45, 46. From the 47 element, it starts with NA. Now let me explain why is that. Usually, when we are generating this number, it's not an integer. It's a float number. Just like before we turn that into as integer. Let's just rerun this code. It's a float number, and because some reasons, the computer never store the numbers like the exact numbers. It stores like correct to some digits. Well, float numbers maybe 8 digits, double 16. So whenever it gets to 10 to the power 16, or if you use float numbers, whenever it's 10 to the power of 8 something, I didn't remember that clearly. As you turn that into integer, it's not safe because you never know what the last digit is. So you get some NA here. To solve this problem, you should use the integer from here, but I'm not gonna demonstrate that because this. How many times do we get? Okay. Well, let's just continue with. Well, you could go as integer here, and you put this one into integer and specify its class. And in some cases, when dealing with really large numbers, like more than 16 digits, it's probably better to use some other things specifically, or at least use some packages that deal with more than 16 more than 16 digits, and there are lots of packages that does that. But they are not in the basic data type of R. Okay. Now we are after generating sequence. Okay, and another thing is that you could transform a list of number to another list of number. Let's just start with I want x. Like I want to plot some functions from -5 to 5 by 0.1. Now I get and I want to plot y is x squared. Now, what is y? What is y? What is interesting is that instead of calculating or looping from one, say one element to another one, when you put y equals x squared, it squares the vector. It doesn't take the vector and just multiply it by itself. It multiplies elements by elements, just like matrices. And if you want to go some vector multiplications, dot multiplications, and matrix multiplications, you do have to use something called matrix multiplications. But this correspondingly like manipulation is sometimes very convenient. Like I want to plot xy. Ta-da! There it goes. And to make it turn out nicely, we use type is L. Wait. And this is my parabola. Cool. And, so this is sequences. Now this sequence is a 1D thing. It's a list of numbers, and like in C, is sorted by column instead of row. To create a matrix, like lots of other programming languages, you start with matrix, and you have to go see something. I'm just gonna create a 3 by 3 matrix. Now you get what I mean by creating it by column. 1, 2, 3, folded 4, 5, 6, and then folded 7, 8, 9. Okay, but the second number actually specifies it row or column. If you get no number of the numbers, a list of number you want to put in the matrix, you usually just have to specify row number or column number. For example, I go from 1 to 25, and I go 5, pretty good, and 1, right. Now what if it's not? What if I guess something consists of 12 elements. Now if you get 12 elements, you could go 2 rows, 1 row 12 column, 2 row 6 column, and lots of other combinations. Now what you want to specify is the column number is 12, for example, and the M2 is this, and I got something called M3. Well, and same. This time I want the row number to be 3. And I got M3. What is M3? You got 3 rows. And it still goes this way. Okay, but what if I want? What if I want 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, 11, 12. By column, the only thing you have to do is to specify that I want it by row instead of by column. I got 4 columns, or you could put 3 row. And here's the key: by row. And you put a Boolean vector true here. Now watch M4. So our answer turns out nicely. Alright, that's matrix. And you could always do it the other ways. Let's just go defining matrix. Yeah, what if I want the second row? Oh, and this is very very intuitive. The first number, the first number of this index before the column is the row number, and after this is the column number. So if I want the first column, or I want the second column, I go this 2, 6, 10. Now, the problem of this is that it sometimes turns to with the vector, which is maybe not very safe when doing calculations. And there's some ways you could try to avoid that, but sometimes it is very useful considering data structure, because it's always trying to use the least dimension of the data, if you pronounce it like this. I don't know, but the first column 159 there, that's not surprising. And if I want a second, and 1 second, what if I want the second and the fourth column, you go this, and it turns out to be a matrix. This is different. And this time I want M4 from column from row 1 to row 2, and from column 3 to column 4. And this is where it comes from, right? This part, and calling it matrix because you could also go. You could try to turn matrix into vectors. M. Now what is V? From 1 to 9. Now if you want to go by V4 S turn M wait, or I can't use that. M4. Then what is V4? Now if I want this to be by row, one way we can do is to transform. To transpose this matrix. We just use T, and yeah, or we could undo that. It's better that way. If you want to override to M4, if you don't want to override to some, if you don't want to write to any of the variables, but just to view it, you could go T and M4, and it automatically. This is the equivalent of print T M4. But you could substitute that or use it as the input as other factors, like my v4. Let's just overwrite it as vector transpose of M4. Good. V4. How was that? Okay, that's for the matrix. Now there are other thing about matrix. Matrix or vectors, we are currently using the square bracket to do this. That could also apply for multidimensional array. Wait. And similarly, if you get 1, 2, 8, in class A is just integer dimension of A. It doesn't have any. And you could go now this time we are turning to a 3D dataset because they actually have 3 levels of matrices. Sorry, 2 levels of matrices, 2 columns, 2 rows, and we could use dimension bracket A and assign it to somewhere. Now this doesn't seem reasonable for many programming languages, because what you see is that you take the output of some function and assign the output of some function to a list of numbers. This is not going to be feasible for lots of things, but this is sometimes good for R, because it's intuitive in statistics. Well, we will get to explain that later. And also there are lots of different ways you could call a vector. For example, my vector is assigning some name. A is 1, B is 2. Now, what is my vector? Now, instead of saying 1, 1, 2, 2, it says A is 1, B is 2. Now, I could go some. You could call the elements of the vectors by using the name of the vectors. For example, I got square bracket quotation mark A, and it tells me in this vector A equals 1, you could assign A to other values, and if you could call A is 2, but in this vector this A is 1. This is different, right? And you could also go say 1 here, because of this first element. You could rearrange it, or you could put 2 here and get B, or similarly you could go, this is tedious. Now just calling, let's call it index, and let's just go, well, after we define the dimension of A is the, after we get the dimension of A is that before we override it, we could go A, and what's good about R is that in the output it often gives you the it often use the R syntax for output. For example, I want to find the first row, second column, first level. I put 1, 2, 1 here, telling me this is 3. You could try for other things, and you could select one level by just doing that. That's the first level. And if you want to slice a level that I want any vector that is in the first row. You could go this. Fair enough. 1, 5, 3, 7. But you gotta be some kind of careful about the arrangement of the number, because it's sometimes different from what you had to expect. Okay, that's the index. Now, there are some other kind of data types. List. My list is, let's just sign it. Let's just list it like I'm still doing A is 1, B is 2. Now you don't have to follow this format, but I think this is clear because if you get lots of catalog, C is if you get odd of contents, and D you the wait, what's the escaped file? Put like wait, this is my list, and you could go my list, the first element, well, similarly, or you could go my list $1, oh sorry, $A, to call if there's something named A in this list. And you could also list what does it mean? My list of this is not a good name for that. Is list my list refer to my list. Now this is different because if you just put my list here, it's gonna have no name. And also I got another list, my list of list. Now what is it? You get multiple levels, and another way of viewing it is use this str, my list. Wait. list of 4, list of 2. This is the first list, second list, and you could go, if you want the first my list here, you could go from this large list, go to square bracket 1. Now this is the first one, and similarly the second one, or you could go, what's the name of the first one? What's the name of my list? First list is my list. So you could also call it by the name. It's the first. It's like the same thing. If you want to find somebody, I'm assuming the name is unique. You could call by using his name or using his number, like identification number. And in this list, you could use star sign first list and get the same result. Now I only want this thing. I only want A in my first list. So what do you do? Or you could go to bracket A, and then you could, the either way is fine. My list. You could go 1 and then dollar sign $A. Well, but it's up to you to choose the best name of it. And I want to know what are the names. Well, sorry, I can't do it from this for data frame. Now in this thing, A is equal to 1, and again I assign A equals to 2. What's gonna happen is that if I put and the A is 2, but my list of this first one, A, is still 1. That's not in the same level. As global environment, you get a variable named my list, and another variable called my list of this, and another variable called A. And within this, you could click on that, and RStudio should take you to a structure of that, and you could go first list. A is a double 1. Okay, I guess that's clear enough. And yet another data type, data frame. This is probably the most commonly used as data table. You could read data type frame from CSV file, read it from Excel file, generate it from MySQL server, or you could use the most commonly used way for practicing summary statistics is to use the R datasets. These R datasets, which you could access by a data bracket. And here goes. There are all the data sets you'll get because, oh, actually, what is that? Volcano. I want volcano. It's showing me the data set. It looks like something like a contour map in geography. And what are the other thing? Faithful. It's time series data for no time period data. Cars. You have 2 scrolls. You get lots of different things like Huron. It's like a time series for analysis, and I like to use the iris. Anderson's iris data. Let's just say Wait. Now, this data type set is larger than that of we have defined, but this all consists of 5 variables in order. Usually in R, we use one column for one, let's say, data variables or dimension instead of using rows. But you could always do matrix transpose, so it will not matter really much for in most cases. Now, a dimension could be Boolean vector, could be character, or could be factors. Like the species, you actually use the word to get those different species of things of iris classified, so that we know which type is which. Now there are lots of interesting stuff about this data frame, but let's just have a look at the structure of this. Now here's why we want to use this data frame. 150 observation of 5 variables, simple length, which is a numeric vector, numeric vector, numeric vector, and the last thing is factor. There are 3 levels. 3 levels actually means there are 3 different words. If you cancel out, if you take out all the repeating words, we get 3 species, and it has the actual meaning. So, and you could also go summary. You don't have to attach the file. Yeah, and I'm not going to introduce you to the statistic here. But anyway, it's important to know that the data table is a favored data type for doing statistic, especially summary statistic in R, and also some plotting. Like if you use ggplot, you're gonna use data frame a lot. Now we could also use our data to make a data frame. Like, for example, I got whatever. Okay, this is A. Now I want my data is data frame A is R A, and to make it less tedious, let's just make B is sig long A, so that it has same length. We're gonna add that by 2032. Run if I want a random by 1. Okay, so that's getting interesting. Frame A is A, B is B. My data. Where's my data? Pretty awesome, right? And by this, now we can still see A and B, right? But if we remove A Now what happens if we and remove B, so we can't see them anymore. Now there's no A and B. Only my data list, a list of lists. Now what's interesting about this thing is that when you type A is not found, B is not found either, right? Not surprisingly, but if you attach my data, if you get A, now it appears again. So the things in the variables, the numbers in the data frame can be escaped to global environments if you go attach, or you could remove them, or you could detach a frame. You have a detach frame. What happens if you detach? Okay, now it is detached, and it is missing again. So this is a pretty awesome property of the frame. And now let's just, if we plot some frame, it's gonna give us lots of relationships, and the frames are two-dimensional, but it's important to know that it's kind of what we usually got as some discrete values. Now for some real value gets from real world, for example, this kind of iris, you could interpret it as five-dimensional because you got five variables, and if you're not considering grouping as a property, so when you plot it, like I plot this iris here, you got lots of things going on this graph, and these things which are not doesn't make lots of sense, at least, and you should remove some of them to make general intuitions. And for our data, it doesn't matter really much because okay, well, we're just plotting B with respect to, well, I guess A. What if you do the other way? What if you do? There are different ways you could do this, because if you want to shift the variables, you inevitably have to arrange the sequence of that. Alright, that doesn't make a lot of sense. But about plus function, if you recall that you could get access to variables that have a name by using the dollar signs, something, or you could say you want to access by like a matrix by using the square bracket. You can make the visualization make a lot of sense, because like I want to, without attaching this, I want B with respect to A. Oh, okay. This frame is a two-dimensional thing, so it should be a matrix. I'm actually wanting the first column and second column Now we get the same thing. Now the other way around. Let's just copy and paste. Okay. Okay. And the same for iris. Now I want now instead of applying all of it, I just want pedal length with respect to pedal width. Oh, sorry, sepal width. Let's say if it has some relationship. Yeah, it does. And you could subset the data to just look at the iris of some species if it follows some certain relationship or lies in a certain range, or or you could also do something like you could go from the plot iris. If you go plot iris, this is. Wait a second. I think some insect is flying. Right. We don't want this thing. Species. Because it's not making any sense. Now, what we do is we know that the structure that they have 5 variables. I want to remove the 5th one. I just use the first 4 columns. That's pretty simple. Or recall that you can always find other things, or the other ways of solving problems. We have the same thing. Yeah. It's better to put this column here. Alright. Now you could always also do that. This is the same thing. Plot doesn't change because you're doing the same plot within the same region. So it is basically saying if you deselect some column iris, if you deselect the last column, you get a data set of this not having the species. Okay, let's if you get back to the Boolean vector, now I want this to be, I want all the data, I want all the numbers in the set being studied to be, say, setosa, this kind of iris. Now, species. Here's, wait, what happened? Oh, it's lowercase. It's lowercase. I want this. Okay, it's a subset. Or you could subset with some argument. Now you don't have to put the dollar sign here. And instead of getting from 1 to 4, I want all the 5 variables, so that I can see, yeah, there are all in this species. So that's the basic use of the data structure in R. So hope you could see the advantage of and some disadvantage of managing data in this way, and then with some packages you could further do some further manipulations of all these contents we have introduced. Alright, that's all.